Let's solve this differential equation, y double prime plus 2y prime minus 15y equals 0, subject to the initial conditions y of 0 is 0 and y prime of 0 is 1. The first thing we want to do when solving any second-order constant coefficient linear equation like this is to obtain the characteristic equation. In this case, it's r squared plus 2r minus 15 equals 0. This is a quadratic equation whose coefficients came from the coefficients in the differential equation. We can actually solve this quadratic equation by factoring. It factors as r minus 3 times r plus 5 equals 0, and therefore the solutions of this characteristic equation will be r equal to 3 or r equal to negative 5. We use these values of r to write down our general solution for the differential equation. These values of r become coefficients inside exponential functions. So for example, we'll have e to the 3x and e to the negative 5x. Each of those functions is a solution of the differential equation, and the general solution of the differential equation is obtained from making linear combinations of these solutions. So y equal to a e to the 3x plus b e to the negative 5x for any values of a and b will be a solution of the differential equation, and this is our general solution. To find the solution that satisfies these particular initial values, we're going to plug these conditions into the equation to solve for a and b. One of our conditions involves the value of y of 0, the other involves the value of y prime of 0. So let's go ahead and find y prime. In this case, the chain rule tells us it's 3a e to the 3x minus 5b e to the negative 5x. Now if we plug in our initial conditions, the first one is going to tell us that 0 is equal to a e to the 0 plus b e to the 0. The second initial condition tells us that 1 is equal to 3a e to the 0 minus 5b e to the 0. Consequently, that means we want to solve this system of equations. 0 is equal to a plus b, and 1 is equal to 3a minus 5b. Solve this system of algebraic equations using whichever algebra technique you feel most comfortable with. You should find that a is equal to 1/8 and b is equal to negative 1/8. If we use those values for the parameters a and b, we can write down y equals 1/8 e to the 3x minus 1/8 e to the negative 5x. And this is the solution of the initial value problem.